The sky is red. Not the romantic red of sunset, not the angry red of a storm approaching. This is different. This is the red of a dying star swelling to consume everything you've ever known. The air itself feels heavy, thick with heat that doesn't just warm, but suffocates. The oceans have been gone for 1 billion years, the mountains worn down to nothing, and above you, filling half the sky, a crimson giant pulses with the heartbeat of its own demise. This is Earth, 5 billion years from now. But let's start at the beginning. Not Earth's beginning. The Sun's. 4.5 billion years ago, in a cloud of gas and dust, gravity pulled hydrogen together, compressed it, heated it, until fusion ignited and a star was born. Our star. For all that time, longer than you can truly comprehend, it has burned steadily, reliably. It rises. It sets. It gives life to everything that has ever lived on this planet. We think of it as eternal. It is not. The Sun is middle-aged now. A yellow dwarf, astronomers call it, though there's nothing dwarf about something 1 million times the volume of Earth. It's been burning hydrogen in its core for billions of years, fusing it into helium. This is what stars do. This is what keeps them alive. But here's what most people don't realize. The helium just sits there, accumulating, building up in the core like ash in a fireplace. And one day the hydrogen runs out. Not soon, not in your lifetime or your children's lifetime, or in the lifetime of any civilization we can imagine, but it happens. In about 5 billion years, the core becomes pure helium. The fusion stops. And for a moment, just a moment in cosmic time, the Sun's heart goes cold. Gravity squeezes the core, the temperature rises, and suddenly hydrogen in a shell around the dead core ignites. This is when everything changes. The Sun doesn't fade quietly into darkness. It doesn't simply wink out like a candle. Instead, it begins to swell. The outer layers expand, pushed outward by the fury of that burning shell. The Sun grows larger and larger and larger still. A red giant is born. First, Mercury vanishes, consumed, vaporized in an instant as the Sun's surface reaches out and swallows it whole. Then Venus, beautiful, hellish Venus with its crushing atmosphere and sulfuric clouds, gone. And Earth? Earth has been dying for a long time by then. 1 billion years before the Sun becomes a red giant, something else happens. Something quieter but just as deadly. The Sun, even in its stable phase, grows slowly brighter. About 10% every billion years. Doesn't sound like much, but that 10% changes everything. The oceans begin to evaporate, not boiling away in steam and drama, but molecule by molecule, atom by atom. Water vapor rises into the atmosphere, and here's the cruelty. Water vapor is a greenhouse gas. The more water in the air, the more heat is trapped. The more heat is trapped, the more water evaporates. A runaway effect. The same thing that happened to Venus 3 billion years ago now happens to Earth. The planet heats up. The oceans disappear into the sky. The atmosphere becomes thick, choking, lethal. Any life that remained, any stubborn microbes hiding in the last wet places, boils away to nothing. The Earth becomes a desert, a smooth, baked rock orbiting a brightening star. This is 1 billion years from now, long before the Sun's final transformation. By the time the Sun becomes a red giant, Earth is already dead, a corpse world. But there's a strange possibility here, one that scientists debate. As the Sun swells, it loses mass. Solar wind carries away its outer layers, and when a star loses mass, its gravitational grip weakens. The planets drift outward. Earth might move just far enough out to avoid being swallowed. Instead of burning inside the Sun itself, it could orbit just beyond the red giant's surface. A charred ball of rock, its surface melted into a global ocean of lava, glowing red hot from the heat of the bloated star. Imagine that. The planet that once held forests and oceans and cities and dreams, reduced to a molten sphere reflecting the dying light of its parent star. But the Sun isn't finished. For hundreds of millions of years, it burns helium in its core now, fusing it into carbon and oxygen. The red giant phase is stable, almost peaceful. But helium burns faster than hydrogen, much faster. And when the helium runs out, the core contracts again. There's a final ignition, a shell of helium around the carbon-oxygen core. The Sun pulses, expands and contracts in thermal oscillations. Each pulse throws off more of its outer layers. Beautiful shells of glowing gas drift into space, lit from within by the exposed core. This is what astronomers call a planetary nebula. Not because it has anything to do with planets, but because through early telescopes they looked round and planet-like. The sun's outer layers peel away like the petals of a dying flower, and at the center, what remains? A white dwarf. A star no larger than Earth, but containing more than half the sun's original mass. A sphere of carbon and oxygen so dense that a teaspoon of it would weigh tons. No fusion, no fire, just the residual heat from billions of years of burning, radiating slowly into space. The sun's final form. It will glow dimly at first, white hot from leftover energy. But with no fusion to sustain it, the white dwarf simply cools. Over trillions of years, longer than the current age of the universe, it fades from white to yellow to red to brown. Eventually it becomes a black dwarf, a cold, dark sphere drifting through space, the final grave of the star that gave us everything. And Earth? If it survived the red giant phase, it orbits this cold remnant in permanent darkness, a frozen rock circling a stellar corpse. The temperature approaches absolute zero. No light, no warmth, no memory of what once was. This is the end. But here's what strikes me most about this story. Right now, today, the sun is shining. You can see it if you look up, feel its warmth on your skin. Every photon that touches you began its journey in the core of the sun, created by fusion, bouncing around for tens of thousands of years before finally escaping to cross space in 8 minutes and land on your face. That light is temporary. Everything is temporary. The civilizations we build, the art we create, the love we feel. All of it exists in a narrow window between the birth and death of a star. We are the universe experiencing itself, yes, but we're also the universe knowing its own mortality. 5 billion years feels like forever, and maybe it is, for us. Maybe humanity will be gone long before the oceans boil. Maybe we'll have left Earth, scattered among the stars, become something unrecognizable. Maybe we'll find a way to move the planet, to shepherd it to safety. Or maybe we'll simply accept that all things end, and that's okay. Because the sun isn't just dying, it's completing a cycle. The carbon and oxygen in that white dwarf, the elements thrown off in the planetary nebula, they'll drift through space, mix with new clouds of gas, and perhaps, billions of years after our sun goes dark, those atoms will collapse under gravity and birth new stars, new worlds, new chances. The universe doesn't end, it transforms. Death and birth are the same process, viewed from different angles. Stand outside tonight, look up at the stars. Every one of them is doing what our sun does, burning, living, dying. Some have already exploded. Some will burn for trillions of years more. You're looking at a sky full of temporary lights, but they're beautiful, aren't they? Even knowing they won't last forever, maybe especially knowing that. The sun's final day is coming, not tomorrow. Not in any tomorrow you need to fear, but it's out there, in the deep future, waiting with the patience of cosmic time. And somehow, that makes today matter more.